Hi, grade 6. Welcome back to Nelson Math, Chapter 8, Section 6, Area of Polygons. We're going to be doing today something you've been doing for many, many years, breaking down or decomposing a shape and then finding out the individual shapes to find the sum area of the shapes altogether. So in the past, you may have seen three rectangles stuck together in some sort of an irregular shape. You break it down into three rectangles, add up all three rectangles, and go from there. We're doing something very, very similar today. The difference is that we're using two new kinds of polygons that you learned in Chapter 8. One of those would be a parallelogram, and the other one will be a triangle. You see here that you have a polygon, and it happens to be made up of two smaller polygons. If we wanted to find out the area of this, we could, if we wanted, count squares. That's completely legitimate. So 1 square, 2 square, 3 squares, 4 squares. We could do that all the way through. But there is a much faster way of doing it now that you're in grade 6. You have to look at this and ask yourself, how can I cut this up to make it easier to find the area? So how can I put lines here so I could see what those different areas are? So right here, I put a line here. Let's make it a bit thicker so you can see it. I put this line right here. So with this, I created two smaller shapes with the same area once you find their sums. So I have here the polygon, the parallelogram, and the area rule for a parallelogram would be base times height. So let's count our base. 1, 2, 3, 4, 5, 6, 7, 8. The base is 8. The height is 3. So if we insert our text box, we have an area for the parallelogram of 8 times 3, or 24 centimeters squared. And now we can find the area for this triangle. Remember, we have to find base times height. So our base is 1, 2, 3, 4, 5, 6, 7, 8. So I'll put 8 centimeters times, and now for our height. Our height is not this diagonal. Our height is always the perpendicular from the base to the top, or from the base to the bottom. So it would be 1, 2, 3, 4, 5. So times 5 centimeters, but we have to divide this by 2. 8 times 5 is 40, divided by 2 is 20. So 20 centimeters squared. Like that. So if I wanted to find the sum of these two squares, I simply add them together, which would be 20 plus 24, which is 44 centimeters squared. That was one way I could have cut them up. There is another way I could do it too. I don't necessarily know why you would ever do it this way, but I will show you a different way. You could take this, so I'll just put that line there, and I'll thicken this line up too. Make it easier to see, and I'll do this. And we'll thicken this line up too as well. Like that. So if I was so inclined and I wanted to find a different way of doing it, I could take and make 4 smaller pieces. Here's one triangle, another triangle, another triangle, and a rectangle. So I could do the exact same thing, but instead of just using two shapes to make my larger shape, I'm using 4 shapes. So let's see if we can do it this way. Here we have a base of 2, a height of 3. So 2 times 3 is 6, divided by 2 is 3. I'll just do a little bit of a running tally up here. So 3 centimeters squared, and I'll use short form here. So this is 3 centimeters squared. This one is 2 times 3 divided by 2, which is also 3 centimeters squared. Here we have a rectangle that's 1, 2, 3, 4, 5, 6. 6 times 3 is 18, like that. And here we have a triangle with a base of 1, 2, 3, 4, 5, 6, 7, 8. 8 times 1, 2, 3, 4, 5. 8 times 5 is 40, divided by 2 is 20. So if we add these all up, 3 plus 3 plus 18 plus 20, it is 44 centimeters squared. Once again, you probably wouldn't do it that way, but this will work. In some of the more complicated polygons that you see, you are going to have to cut it up into smaller polygons. Please get creative and look for efficient ways of doing this, plus some other ways you feel most people would not have looked for. Thanks, everyone. Have a good day.